Today in Algebra 1, in Chapter 2, Section 7, we're going to talk about finding square roots and comparing real numbers. Let's start off by recognizing the square root symbol. This is a square root symbol, and it's also called a radical. So if it says what's underneath the radical, they're talking about what is underneath the square root sign. It's a radical. When finding the square root of a number, let's go backwards. If we know that 3 times 3 equals 9, then we can say that the square root of 9 equals 3. So the square root of a number is just the number that you multiply by itself to get the number that is underneath the radical. Okay, let's do another example. If 4 times 4 equals 16, then we can say that the square root of 16 equals 4. Okay, if a number is underneath the radical or the square root sign, then you're looking for the number that will multiply by itself to find that number that's underneath the radical, and that is the square root. Let's do these 3 examples. You'll notice that the square root of 36 has a positive sign as well as a negative sign in front of it. That means we are going to use the positive integer as well as the negative integer for our solution set. When we take the square root of 36, we know that 6 times 6 is 36, so the square root of 36 is 6. And now we have to apply this positive and negative sign over here. So we're going to have 2 answers, a positive 6 as well as a negative 6. All right, on the second problem, the second example, the square root of 49. You'll notice it does not have the positive or negative sign like the previous problem did. So we'll say the square root of 49. What times itself is 49? It is 7, a positive 7, because the negative is not included in front of the radical. The last example on this page is negative square root of 4. So we are only going to use the negative answer of this. The square root of 4 is 2, because 2 times 2 is 4. Okay, now let's look at approximating square roots. If we know that the square root of 25 equals 5, and the square root of 36 equals 6, then the square root of 32 has to fall somewhere between the whole numbers of 5 and 6. So we can approximate that that's going to be somewhere in there. We don't have to know exactly what it is all the time, but we do need to recognize that it is between 5 and 6. Let's practice another one. How about if they say the square root of 54? Well, obviously that's not going to be a whole number, so let's find the numbers on each side of it that would have a whole number. Okay, the square root of 49 equals 7, and the square root of 64 equals 8. Okay, so that because we know that 54 lies between 49 and 64, then the square root of 54 must lie between the whole numbers 7 and 8. Let's do one more example of approximating a square root. If the problem is the square root of 103, then we know that the square root of 100 equals 10, and the square root of 121 equals 11. So we know that the square root of 103 has to be somewhere between 10 and 11. Obviously, it has to be closer to 10 because 103 is closer to 100 than it is to 121. Therefore, its square root would have to be closer to 10 than it is 11. So far, all the numbers that we have looked at have been rational numbers. Everything that we look at for a good while will be under real numbers. And so far, everything we have looked at has been rational. Now remember that a rational number is a number that can be written as a quotient of 2 numbers. It can be a fraction. And then under the subheading of rational numbers, we have integers as well as whole numbers. Now in this lesson, we're going to go ahead and jump into the irrational numbers underneath that heading of real numbers also. Irrational numbers cannot be written as a fraction or as a quotient of 2 integers. They are numbers like the square root of 2 and negative square root of 14. Anything that just goes on and cannot be written as a quotient, has no pattern or anything like that. So we have these square root numbers as well as numbers like pi. Pi is an irrational number because it goes on forever, cannot be written as a fraction or the quotient of two integers. So this is the first lesson that we have seen, the irrational numbers. Okay, so let's hit the high notes real quick again of this lesson. Okay, we are talking about square roots. This is the square root symbol. It can be called a radical. That is something that's important. I would write that down. I would know that that might possibly be on a quiz. Okay, the square root of a number is a number that when you multiply it by itself, you get that. So the square root of 25 is 5 because 5 times 5 is 25. If you have to estimate a square root because it doesn't have a whole number, such as the square root of 32, we know that the square root of 25 is 5 and the square root of 36 equals 6. And because 32 is in between 25 and 36, its square root must then be between 5 and 6. Okay, then we also know that we are now adding irrational numbers into our vocabulary, and an irrational number is one that cannot be written as the quotient of two integers. It cannot be written as a fraction, and so those numbers are going to be the square root of 2, the square root of any number that is not going to have an integer as an answer. So if I were preparing for a quiz, I would know the radical sign. I would know that. I think that's something important. I would know that to estimate the square root of a number, that it would have to fall between the whole number square roots, the numbers that have a whole number square root. And I would know that an irrational number is the square root of a number that does not have an integer solution. Those would be some important things, some high notes of what I would know for a quiz.